Okay guys, so we have a PowerPoint here on identifying and collecting like terms. So like terms, they are terms with the same variables raised to the same powers. So we have both of these conditions needing to be required in order for the terms to be like each other. Okay, so what we're going to do, we're going to go through an example here, identify the like terms in the list. What we're doing is we're looking for like letters and also having like powers. There we go. So we have 3T and 7T. Both of them have only a single T in it. Now, the variable, the coefficient, I should say, the number at the front is not relevant when we are considering whether two terms are like each other. So as you can see, we have a 3 and a 7. That doesn't come into our decision making when we are considering whether two terms are like each other. We're only looking at whether they have the same variable and then the same power on those variables. Okay, so when we have a look here, we have 5w squared. Well, we need both the w and also the squared on our w, which is the case for this one, because we come over here, w, yes, squared, yes, good, they are like each other. And finally, 9v and 8v, well, that one's not too bad. V and v, they are like each other. We aren't worried about those numbers out the front. They can be different. They can be like also, okay? They could be the same number, but we only need to consider the variables and the powers whenever we are looking for like terms. So what we're doing is we need to identify the like terms in the list. Some terms may not have a like term, okay? All we're going to do, we're going to run through this list and see how we go. So let's start from left to right. So we have negative 8y. What we're going to do, we're going to run through and see, well, where else do we have just a y, okay? So for xy, well, there's an x, so that is not like, it is different. There are different variables. We only want a y, okay? This one, x squared and y, so the x squared's extra. This one's good, okay? Y, only y. And here we go, 5y, only y. All the other stuff has different variables or different powers, so that is not like, and it is not what we are looking for. Let's change our pen color. So this one here, we have 4xy. So this one, even though there are x's and y's, the powers throw us off. The powers are not like. There's no powers in our 4xy. And there's actually no terms that are like 4xy. All the rest have powers, so we're good. Let's change color again. Change to purple. So this one, we have 12x squared and y. So we need an x squared and we need a y. This one has xy squared. So it is not like, it is not the same. We need the x squared and 1y. So that is over here. Okay, see the difference? The squared is on the y in this term, which is why they are not like each other. I can see that there's no x and y squared, so that one doesn't have any like terms. So I'm just going to do a yellow one by itself for that. And then the last one's there, I can kind of see as I change my pen color. Oh, where am I going? Okay, 8x, well, we're looking for an x, which is just here. There we go. I feel like we explain that one as we go. So negative 8y and 4xy are not like terms. Well, they're not like terms because this one, negative 8y, doesn't have an x. It needs to have an x. All the variables need to be the same and all the powers need to be the same. C, we're going to provide our own like term for 4xy. So you can pick your favorite number. My favorite number is number 7. And then x and y. The variables are the important things. So you could have any number out the front you want. Minus 10, 124 million, doesn't matter. As long as you have an x and a y at the end there, the variables are what makes them. Combining like terms. So terms can only be added or subtracted when they are like terms. When combining like terms, the coefficients change, but the variables stay the same. Guys, that is a perfect description of what we're going to be doing. So I recommend you writing those down. We're going to have a look at some examples and some non-examples. So first things first, we have 8x plus 2x. You should always check that those terms are like. That is your first step. And we can see that they are. X, x. Well, they're like. Same variables, same powers. So what we can do is we can now add those coefficients or add those variables out, the coefficients out the front, the numbers. 8 plus 2 is 10, and our x comes along. So it's kind of like saying if I have 8 x's and I add 2 more, how many x's do I have in total? Well, you would have 10 x's. Same thing here. So we have a, b, and ab, so they are like terms. 5ab, I take away 8ab. I just simply add or subtract those coefficients, those numbers out the front. 5 take away 8 is minus 3, ab. This one here is that tricky question because they're not like. There's an x and an x, so that's good, but there's a y and there's no y. So if we were to try to, simplify this or combine these two terms, there's nothing that we can do. They aren't like each other. We can't combine them because they're not the same thing. So when you're ready, unpause it and we'll go through the answers. I'll run through them relatively quickly. X and x, so they are like terms. 3 plus 4 is 7x. 8y take 2y, so they're both y's. They're both like each other. 8 take 2 is 6, and we're still talking about y's. AB, good. They are like each other. I have 12 ABs. I add 3 more. I have 15 ABs in total. 9A, take away 1A. Well, I have 8 A's left. Good. XY squared, XY squared. So they are like each other. Our variables and our powers are all the same, which is great. I have 15 XY squareds. I take away 6. I should have 9 XY squareds left. ABC, ABC, good, they're like. I have 30 ABCs, I add 1 more. I have 31 ABCs. 8A plus 4A take 3A. Well, all 3 of these terms are like each other because they all have an A in them. So if I had 8 and I added 4 more, I'd have 12, but I took 3 away, so I only had 9 left. YZ squared, YZ squared, YZ squared. All correct, all like. 12 take away 5 is 7, add 3 more, I get 10 YZ squared. Hopefully you guys agree. This is where we get a little bit different, okay? So we're now no longer adding or subtracting terms. We do also need to consider what happens when we multiply our terms. So when asked to simplify an expression such as 2a times 3b, we need to follow these steps. Step 1, we expand the problem and show all multiplication signs. We then rearrange the problem so that coefficients are first and variables are second. Multiply the coefficients together and then combine the variables. Your final answer should not contain any multiplication signs. Guys, I recommend you write those steps down because they are 4 very easy to follow steps that I think you guys will benefit from. This is how we might write our problem up here. Okay, so this is how we might be given the question, and so this is that first step. 2 times a, okay, because there's no multiplication symbol between the 2 and the a, we know that it is 2 times a, and then it is times 3b. So we move all the numbers out the front, all the variables out the back. We multiply the numbers together, so 2 times 3 is 6, and then we combine the variables there. Okay, so just like in shorthand, we don't need to write in the multiplication symbol, because when we don't have the multiplication symbol in there, okay, it is implied, or it tells us that we are doing multiplication. So here's some practice questions, guys. If you'd like to have a go at these yourselves, I recommend pausing the video and coming back when you're done. We're just going to have a go at these. So I might do my working out along the page instead of down the page, just because I don't have as much room as you guys. So I might have numbers out the front, so 8 times 3 times x times y. And what you guys might notice here, and might have noticed in the previous example, is that we don't need the problems, or the terms, sorry, we don't need the terms to be like when we are multiplying. One big difference. To add and subtract, they do need to be like. To multiply, they don't need to be like. Okay? Very important. Don't need to be like to multiply. Okay. Rightio, so numbers out the front, 15 times and 4 is out the front, times AB times A. So 15 times 4 is 60. And what I'm going to do here is I'm going to actually write this in, I'll tell you what, I'm going to fix this up. I'm going to rewrite this really quickly. Times A times B. I might write it like that instead. Because what I'm going to do is I'm going to notice that I have an A times an A. And hopefully you guys can remember from just the other lesson, A times itself 2 times. I can write that as A squared times B on the end. Again, numbers out the front, so I have a 9 times a 5 times an A times a B times a B times a C. And then I'm going to tidy that up. So numbers multiplied together, 45. No, I'm just going to skip that one. So I have B multiplied by itself twice, so I get B squared, and then a C there. Here we go. So this one, numbers out the front, 4 times 2 times 3 times x times y times z times x times z. 4 times 2 is 8 times 3 more is 24. And then let's have a look at these letters here. So I have x times itself 2 times, so I have an x squared. I have a y times itself 2 times, which is y squared, and then a z squared. Hopefully you guys agree with those. That's all there is in terms of examples, guys. If you need to have a look through them again, I encourage you to. There is plenty of worksheets there for you to practice those skills. So please get stuck into them. Email your teacher if you have any questions, and I'll see you next time.